Hey, Steve Sullivan here, Training Supervisor at Rittal Noth America. I'm at a demo cabinet for climate control here in Urbana, Ohio at the factory. And I want to talk to you about industrial air conditioners. Air conditioners play a critical function in switchgear and electronic cabinets. And just like anything mechanical, they require maintenance. Properly maintained air conditioners will save you money, extend maintenance intervals, and prolong the life of your equipment. One of the features on our Blue E air conditioners is called filter monitoring. And what this will allow you to do is to set up a signal that when the airflow starts to become restricted due to contamination or a filter that is becoming clogged, it will experience a temperature rise, and that temperature rise will then signal that you need to replace the filter. So I'm going to walk you through how to set this up on your Blue E air conditioner from Rittal. Okay, so I'm here at the air conditioner. You can see my display right here, and the first thing you want to do is make sure that the unit is actively cooling. This will also engage the sensors, which will establish the baseline temperature from this point. My comfort controller is showing 23 degrees C, internal temperature, and since it's steady, there are no alarms, there are no warnings. The keypad, I've got a set key, I've got a Celsius button and a Fahrenheit button, and so I use those to program my comfort controller. So now to go into the menu, I want to press and hold the set key for about 5 seconds until it takes me into the menu, and then I'll use the C or the F button to toggle through. So going up, I go past set point to filter monitoring. Touch the set key again, and it gives me the actual value. 99 from the factory means off. So default from the factory, filter monitoring is off. I want to use the C or the F key to look at what my temperature differential is, my delta T on the sensor of the incoming air through the condenser fan and the external temperature, the air leaving through the condenser coil. This is all in the external circuit. So it's giving me a 5. That's my delta T. I want to remember that for later because I'll use this point then to adjust my alarm condition. So go back to the set key. It's going to ask me to enter the code. I'm going to block out the code for obvious reasons, but you can go into the instruction manual that you have to see what that code is, or you can go online if you've misplaced it and find what that number is. So hitting the button again, it starts with 10. 10 is the lowest threshold level for alarm. So I take 10, I add the 5 from previous to give me 15. And then when I hold the set key down long enough, it's going to give me ACC for accept. Okay, so that's accepted my change. If I don't hold that down and just back away, it's going to flash and it's going to say ESC for escape. What I'm doing now is I want to go back and verify that I've changed my set point. So I go back to the menu, I go to the actual value, and right there's the 15. So that tells me that I've affected my change. Now as I'm looking at the flow chart, which is in the instruction manual, what we've done is upper left hand corner, this is how I enter the menu. So with my set key, I want to hold the button down for 5 seconds. That takes me into what you see here. Set point, filter monitoring, AD is adding your networking or your master slave connection. C or F, I can change between Celsius and Fahrenheit, and then HI gives me some high point changes. So I go into filter monitoring, I hit the set key, that gives me that actual value. Remember that was 99. And then I hit the C or the F, and that gives me the value of delta T. That's where my 4, my 5 came into play. That's the temperature difference, okay? Because this is what this is going to read, the difference in that temperature and how far it goes up. Then I hit the set key again. It's going to ask me to enter the code, so I use the C or the F button to change that number to go to the code. Once I'm at that number, I hit the set key, and then I can go C or F to add my delta T plus 10 all the way to 60. So my range is a 10K change to 60. So I took the 10, I added 5 to that, which gave me 15. 15 became my new number. Okay, so now it's school time. The instructions tell you that to enable filter mat monitoring, the display should be set a minimum of 10K above the temperature difference shown in the program. Filter monitoring is disabled. The code will be 99. So 99, which you saw, tells us it's off. So what it's going to do, it's going to give us a range of 10K to 60, okay? And that 10 is the minimum value. That's the tightest, most sensitive increment that I can put it at for it to trigger an alarm for filter monitoring. Basically meaning that 10 degrees above whatever my number I set in there is, it'll trigger an alarm. And you can go all the way to 60. Don't be thrown by the K. I had a guy the other day on a webinar and I was talking in terms of Celsius and the chart said K, and he sent me a chat saying, hey, you're talking in two different terms. Yes and no. Let me explain something. For what you usually do as far as difference, they're considered the same. And typically, Kelvin is the preferred method in scientific work. So let's say, for example, that on the Kelvin scale, okay, you have the boiling point of water is 373.15 degrees. And then you have the freezing point of water at 273.15. Okay, so your difference here is 100 on the Celsius scale. Boiling point of water is 100, and the freezing point of water is 0. Again, your difference is 100. Kelvin and Celsius are interval scales, and each being 100 intervals between freezing and boiling, they are equal. A change of 10, for example, on Celsius is a change of 10 Kelvin. When you get into Fahrenheit, it's a little different. This is a thermodynamic scale, and we know that the boiling point of water is 212, and we know that the freezing point of water is 32. So many more increments in the Fahrenheit scale. So Celsius and K are the same. Okay, so with that in mind, let's come back here and let's say that on the Celsius scale, 20 degrees is 68 degrees Fahrenheit. And 10 degrees, a 10K change above that would be 30. Okay, so 20 and 10 is 30. All right, 30 on Celsius is 86 degrees Fahrenheit. So here you have a 10 degree shift. On the Fahrenheit scale, it's 18, so almost double. Okay, so in the instructions, when it tells you to go from 10K up to 60, this is how you can program. So if I want to take the most sensitive level at 10, when we went into the controller, we saw that it was going between a 4 and a 5. So let's say my 5 was the differential. So it looked at the temperature differential and it said that that differential was 5. So if I take 5 plus 10, because I was in Celsius, 5 plus 10, then my new trigger point or my alarm point now is 15. So as that filter becomes clogged, it starts at 5. And I was trying to show you how in the display how it starts to move upward. And so it went to 5, and as soon as it would have reached 15, that's my alarm point, and that's when I get an A03 on my display. So that's kind of what's in behind your filter monitoring. What I'm going to do now is simulate the alarm for you. So I'm taking double filter material that I would usually use. I'm doubling up on that, so that creates a pretty restricted airflow. And I'm going to put that into the compartment in front of the condenser fan. And you can see what's happened here. Now there's been a time lapse of about 1 minute, but you can see now that I get a code A03, and that's flashing. A03 is my code for filter monitoring alarm. You can also see to the right as a little red dot or a light that's on my set button. So it's alternating the internal temperature plus my alarm code. Now, to clear that, you have to fix the problem. So what I've done is I've removed the filter material, okay, and then I'm going to go back in, and once you fix the problem and you want to reset or clear the message, I'm going to use the C and the F key depressed simultaneously, and then that will send it into a self-diagnostic mode. This is about a 5-minute test as it checks everything. So we've time-lapsed again, and now it has cleared the code